This is Bob Capetta, and this lesson is on multiplying polynomials. So let's remind ourselves of some basics. If I have x squared times x to the third, what does this mean? X squared, of course, means x times x. X to the third means x times x times x. So we get x to the fifth power. So just kind of remind us that when we multiply things with the same base, we can add the exponents. If I want to do something like this, 2x squared times 3x cubed plus 5x plus 4. In this situation, we're going to distribute. So we can take 2x squared times 3x cubed. 2 times 3 is 6. X squared times x cubed, as we saw over here, is x to the fifth. Plus 2x squared times 5x. 2 times 5 is 10. X squared times x would be x to the third. Plus 2x squared times 4. 2 times 4 is 8, times x squared is just 8x squared. So for multiplying a monomial by a multinomial by a trinomial, it's relatively easy. We just go term to term. It gets interesting when we multiply something other than a monomial. So what if we have 3x plus 1 times 2x plus 5? The way most people teach this, at least in the United States, is to use this FOIL method, which frankly I'm not a real big fan of, but I'll quickly show you one version, then I'll move to something that I prefer. First, the first terms. The first term is 3x here, the first term is 2x there. 3x times 2x would be 6x squared. The outer terms would be next. Outer terms 3x and 5. 3x times 5 is 15x. Inner is 1 times 2x, the terms on the inside. 1 times 2x is 2x. And last, 1 times 5 is 5. So that's the way it is most often taught here in the States. Add all those together. 6x squared plus 15x plus 2x plus 5. Look for the like terms. 15x and 2x is 17x. So we get 6x squared plus 17x plus 5. But again, I don't like that FOIL method because it doesn't generalize to beyond a binomial times a binomial. So I'm going to show you a different strategy to do that same problem. But to start with, we're going to visualize 13 times 12 to motivate this concept. So 13 is 10 plus 3, 12 is 10 plus 2. So let's take a look. I'm going to do a visual of 10 plus 3. So we think that this is a room. This is 13 feet in this direction, 10 feet here, 3 there, and 12 feet in this direction, 10 feet here, 2 feet here. So I'm looking at area. Area is length times width. So that's our model. Area is length times width. So multiplication of 13 times 12 is equivalent to finding the area of this piece of carpeting. So I have 4 pieces. This first piece, 10 by 10, is just 100 square feet. The next piece up here, 3 in this direction, 10 in that direction, is 30. Down here, 2, this skinny piece, 2 here, 10 there, 2 times 10 is 20. And 2 times 3 is 6. So if I add all those together, 13 times 12 is 100 plus 30 plus 20 plus 6, which is 136. And I like to use that model for the problem that we did previously using the FOIL method. So if I have 3x plus 1 times 2x plus 5, I'm going to again think carpeting and how I'm going to construct that area. So here we go. And you'll see that this generalizes quite a bit better. If this is 3x plus 1 here, and this is 2x plus 5 here, I am still thinking of multiplication as representing area. Area is length times width. So 3x times 2x for this piece, 3 times 2 is 6. X times x is x squared. Plus 1 times 2x is plus 2x. Plus 5 times 3x is plus 15x. Plus 5 times 1 is plus 5. So if we add all those together, what do we have? We have 6x squared here, plus 2x, plus 15x, plus 5. And then we look for like terms. There's 2x plus 15x is 17x. And we get 6x squared plus 17x plus 5. And I want to show you how this is a better tool for generalizing polynomial multiplication. So the FOIL method works if it's a two-piece binomial times a two binomial, or a binomial times binomial. What if we have something else? What if I have something like this? What if I have 5x minus 3 times x squared plus 4x plus 2. So binomial, two-nomial times a trinomial, a three-nomial. FOIL doesn't work here, but we can extend the previous model. The previous model was to construct a set of boxes that represent area. 5x minus 3 or 5x plus negative 3. And then x squared plus 4x plus 2. So I'll put 5x here, 5x plus negative 3 here. Then we have x squared plus 4x plus 2. Area is length times width. That's our key idea. So 5x times x squared, x times x cubed. 5 times 1, 5x cubed is the area of this piece right here. That's negative 3, and that's x squared. To visualize that, negative 3x squared. Here we have 5x times 4x. 5 times 4 is 20. X times x is x squared. 4x times negative 3. 4 times negative 3, negative 12 times x. 2 times 5x, 2 times 5, 10 plus 10x. 2 times negative 3 is negative 6. We are looking for the total area, so we're going to add up all of those pieces. So the answer will be 5x cubed plus negative 3x squared plus 20x squared plus negative 12x plus 10x plus negative 6. And then we're going to look for like terms to add all these together. 5x cubed comes first. And then we have our x squareds. We have negative 3x squared and 20x squared. Well, 20x squared take away 3x squared would be 17x squared. And we have negative 12x, the x-like terms. Negative 12x and 10x would give us negative 2x. And then our last number by itself is negative 6. So this was the only x cubed we have, and this is the only number we have. So we finish this off with plus negative 6. And I like to write it without plus negatives, just as minuses, so I'll rewrite my final answer as 5x cubed plus 17x squared minus 2x minus 6. So you'll notice this box method generalized well for a binomial times a trinomial, where the FOIL method only works for a binomial times a binomial. But I want to show another kind of problem that students often struggle with. if I have something like this, if I have c plus 3 squared, many students think that's c squared plus 9. It is not. What does this mean? This means c plus 3 times c plus 3. So we're going to demonstrate that by doing our multiplication box, build this, visualize the pieces, construct the area of the result. So I have c plus 3. I have c plus 3. C times c is c squared. Plus 3 times c is plus 3c. Plus 3 times c is plus 3c. Plus 3 times plus 3 is plus 9. So we can visualize what c plus 3 squared represents. Add all those pieces together. C squared plus 3c plus 3c plus 9, and I get c squared plus 6c plus 9. And it really is no more difficult for us to square a trinomial. So let's quickly do that. Let's look at x squared plus 5x minus 2 squared. What does that mean? That means x squared plus 5x minus 2 times x squared plus 5x minus 2. Or plus negative 2, if you prefer. So we're going to multiply together those two trinomials and see what results. So a trinomial, I need 3 pieces, and a trinomial, I need another 3 pieces. So I've got x squared plus 5x plus negative 2, x squared plus 5x plus negative 2. And let's see what these areas will be in each cell. This cell length is x squared, width is x squared times x squared, xx, xx, x to the 4th. 5x times x squared, 5 times 1 is 5. X times x squared is x to the 3rd. Positive is the sign. Negative 2 times x squared has got to be negative 2x squared. 5x times x squared, again, positive 5x cubed. 5x times 5x, 5 times 5 is 25. X times x is x squared. Negative 2 times 5x is negative 10x. Negative 2 times x squared, negative 2x squared. Negative 2 times 5x is negative 10x. Negative 2 times negative 2 is positive 4. Rather than writing all the terms out, I want you to recognize that they're all here. So I'm going to start with my x to the 4th term. I will circle my x to the 4th term in green. That's the only x to the 4th term. So I will write down x to the 4th. Next, I'm going to look for my x cubed terms. I'm going to circle that in this reddish color. I've got 5x to the 3rd there, and another 5x to the 3rd there. If I add those together, that'll give me 10x to the 3rd. Where are my x squared terms? I'm going to circle that in this blue. Negative 2x squared, 25x squared, negative 2x squared. 25 take away 2 is 23, take away another 2, 21, plus 21x squared, plus, now where are the x terms? I'll go ahead and underline that in green. Negative 10x and negative 10x would give me negative 20x. Plus what's left? All I have left, I'll underline in this reddish, is 4. So I'm able to combine the like terms inside the box. So what's my result? Looking at all this together, we have x to the 4th plus 10x cubed plus 21x squared minus 20x squared. Make sure you can read that. Minus 20x plus 4. And let me go ahead and do one more, sort of in that same vein. We'll do a trinomial times a trinomial. This time we'll do a couple different variables. So if I have 3x squared plus 2xy plus 5y times x squared minus 3xy plus 4y. So this is a trinomial times a trinomial. So again, we're going to need to have a 3 box multiplied by a 3 box. So let's do that and then look for like terms. So I have 3x squared plus 2xy plus 5y here. And the other one is x squared minus or plus negative 3xy plus 4y. You want to fit everything in these boxes. 3x squared times x squared, x to the fourth. This is 3x to the fourth 2. X squared would be x cubed times y. 5y times x squared is 5x squared y plus 5x squared y. Negative 3 times positive 3, negative 9. X squared times x cubed y. Negative 3 times 2, negative 6. X squared y squared. Negative 3 times 5, negative 15. Xy squared. 4 times 3 plus 12 x squared y. Plus 8 xy times y, xy squared. Plus 4 times plus 5 plus 20 y squared. And let us look for like terms. Start with x to the fourth. I only have one x to the fourth term. That's right here. So 3x to the fourth is my only x to the fourth term. X cubed y, you will notice that the like terms are on the same diagonal. I have positive 2 x cubed y here, and I have negative 9 x cubed y there. Positive 2, negative 9 would give me negative 7 plus negative 7 x cubed y. Now we're going to look for x squared y. So we have a couple of these. X squared y here. X squared y squared here. X squared y squared here. It looks like I made a mistake. So, nope, that's not wrong. That's not wrong. 4 times 3 is 12 x squared y. So my x squared y's are where? My x squared y's are here. Here's an x squared y. And here's an x squared y. So if we add those together, what do I get? 12 and 5, 17 x squared y. Now, what do we have left? I have these 4 things. So you'll notice this guy doesn't have anybody else that's in that same family, the x squared y squared family. That's the only one. So that's plus negative 6 x squared y squared. Then what do we have? Then we have the xy squared guys. I have an xy squared guy here, and I have an xy squared guy there. Negative 15 and 8 would be negative 7xy squared. And then the last piece that I have, is right here, which is 20y squared. So let's write this in a somewhat neater fashion. 3x to the fourth plus negative minus 7x cubed y plus 17x squared y plus negative minus 6x squared y squared plus negative minus 7xy squared plus 20y squared. So that is generalizing the process of multiplying polynomials. So FOIL is a nice little trick if all you're doing is binomials times binomials. But if you want something more challenging than that, you need to go ahead and figure out a way to distribute properly. And I believe that that box is the most effective tool you can use. And that will end this lesson.